We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey guys, Mr. Ng here. Lesson 4.2, Basic Probability Rules. Learning target number 1. Give a probability model for a chance process with equally likely outcomes. Use it to find the probability of event. So basically just finding probability. Learning target number 2, find the complement. Hopefully you're thinking of a geometry word that is useful. And learning target number 3, use addition rule for mutually exclusive events to find probabilities. Okay? All right, let's do learning target number 1. Many board games involve rolling dice. Imagine rolling 2 dice, one that's red and one that's blue. We can use the outcomes to develop something. They call this a probability model. Is a description of some chance process that consists of 2 parts. A list of all the outcomes and the probability of each outcome. Okay, number 3 here. The list of all possible outcomes is called the sample space. A probability model does more than just assign a probability to each outcome. It allows us to find the probability of an event. An event is a collection of outcomes for some chance process. Events are usually designed by capital letters like A, B, and C, and so on. And it's fairly easy to find the probability of an event, in that case, of equally likely outcomes. Finding probabilities is all about equally likely outcomes. If all outcomes in a sample space are equally likely, the probability that event A occurs can be found using this formula. So the probability of event A equals the number of outcomes in event A, so that's in the numerator, all over the total number of outcomes in the sample space. Okay. Example 1a. Let's play some games. Let's say you have two 6-sided dice, so I think we said one is, the first one is orange. And they have various numbers on those. And the other one is blue. And maybe it has all the numbers 1 through 6 on there. Okay, that's my 2 dice. We can define event A as getting a sum of 5. We write the probability of event A as the probability of A, or the probability that the sum is 5. A couple of hints on this one, that the sum is the add-in or adding 2 numbers. It's fairly easy to find the probability of an event in the case of equally likely outcomes. There are 4 outcomes for event A. So for example, this one here is 1 plus 1, which would give us a sum of 2. Go ahead and circle the ones that have a sum of 5. Here, 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 and here. There are how many of those? There are 4 of them. So the number of outcomes in event A, or the sum of 5, that would be 4 of them. And let's switch colors here. The total number of outcomes in the sample space is actually all of these, all of the dice. And there are 36 of those. If you divide those, you will get 0.111 or 11.11% chance of rolling a sum of 5. Let's move on to the next example, example 1b. Suppose you spin a spinner with 3 equal parts. So let's go ahead and draw the spinner. Give yourself a visual. With 3 equal sections, you have red, blue, and yellow. Give a probability model for this chance process. So here, I'm just going to write the sample space. And another easy word for it is just all outcomes. What's everything that can happen? And you're rolling this 2 times. So you have red and another red. You can have red and you can have blue, or you can have red and then yellow. Or if you do the blue outcomes, you have blues. You can spin it again and get another blue. You can get blue and then a red, or you can get blue and then yellow. And then this yellow box is saying you're getting a yellow first. You can get another yellow, you can get a red, or you can get a blue. And so if you number all of those, how many are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. So there are a total of 9 outcomes and have a probability, or each of those, of 1/9. So for example, I wanted 2 yellows. So the probability that you get 2 yellows would be 1/9. So each of these would have a likely outcome. B, define event A as spinning blue at least once. Okay, so the nice thing about listing out your sample space like we did there is you get a visual. Spinning blue at least once is you just need to find, let's go ahead and circle those that just have a blue in there. Has at least 1 blue. How many do we get? So the probability of event A happening, which is spinning the blue at least once, or sometimes people call it at least 1 blue. These are the same ways of saying the same thing. How many circles did we get? 1, 2, 3, 4, 5. So we have 5 out of how many total? 9. So 5/9. What decimal is that? Give me a second, pull my calculator. Calculator, come to me. 5 divided by 9. Maybe 0.56, or maybe like 55. Remember, multiply or divide by 100, you get 55.6%. Okay? All right, let's move on to learning target number 2. All right, learning target number 2, we're going to talk about the word complement, but I want to talk about just some basic probability things we've talked about before. The number 1, the probability of any event is between the numbers 0 and 1. And this rule follows the definition of probability. The proportion of times the event would occur in many repetitions. So, super popular example. Every day you should wake up and check out the what? The weather. And so, like, for example, if I look on my computer and tomorrow it's supposed to have like a 76% chance of rain. Notice that 76 or 0.76 is between the zeros number and 1. Okay? So that's kind of like that idea. Number 2. All outcomes together must have probabilities that add up to be 1. Anytime we observe a chance process, some outcomes must occur. So to give you that idea, so for example, let's just say it's sunny tomorrow, and the chances of being sunny are like 2%. Plus it being cloudy, maybe it is like, I don't know, 38%. And then plus rainy would be 0.60. Because all of those equal, I call it the total, which is like the weather, which is 100%. Okay? Number 3, the probability that event does not occur is 1 minus the probability of that event. Okay? And number 4, they call this the complement rule. Okay, where does the word complement come from? Quick geometry lesson. If I drew these two rays here and I put out this angle, that angle is 90 degrees. So if I threw out some kind of line that's cutting it, and if I said that this was 40 degrees, the complement of 40 degrees is 50 degrees because 40 plus 50 equals 90 degrees. Okay? So that's back in complementary angles. Complementary angles. Okay, that's the angle sign. So let's use the rain example. Get another color here. Okay, let's use rainy. Okay, let's use that probability. So let's just say weather is equal to rain plus no rain. Would you guys agree? It's kind of saying yes, it'll rain plus no, it won't rain will equal all the weather outcomes. Well, if I'm saying that rainy is 60, yes, rain says 0.60, and all weather outcomes we just talked about, any outcome has to equal what number? 1. So we can say that 1 equals 0.60 plus no rain. So if we're trying to find the probability of not raining, we can use the complement. So how do you do that? Here we would just subtract 60. And you would get this. The probability of no rain is equal to 0.40. Okay? So we basically took the complement of 0.60, which is 0.40. So I kind of like to think of it as yes plus no equals the weather. And here's some other definitions. The probability of the complement of event A, that's what the little c equals, is 1 minus the probability of that event. And we kind of did that. Over here, I'm doing 1 minus the probability of it raining is equal to the probability of no rain. Because if you add probability of raining on both sides, you get probability of rain, yes rain plus no rain equals 1. So they call those complementary events, right? Like if I said, normally this type of year, I would say to you guys, if it was non-COVID times, I would say, what's the probability of you going to prom? Well, like, oh, I don't know if I want to go or not, right? So yes prom plus no prom equals all the probability that you would be 1. Okay, let's look at example number 2. What's in the mystery box? Mrs. Tyson keeps a mystery box in her classroom. If a student meets expectations for behavior, he or she, the student, is allowed to draw a slip of paper without looking. The slips are all equal size, well mixed, and have the name of the prize written on them. So it sounds like a random chance that you can get any of these. Here's a probability model for the prizes a student can win. So you can get a pencil, candy, stickers, a homework pass, or extra recess time. Explain why this is a probability model. Okay. So first of all, is each of these outcomes, all these numbers, between 0 and 1? The answer is yes. All probability of each outcome is a number between 0 and 1. And then the probabilities of all possible outcomes, So there I'm talking about 0.40 plus 0.25 plus 0.15 plus 0.15 plus 0.5. Oh, that's bad. Let me think. Oh yeah, the equals what? 1.0. So add to 1. So that's why it is a valid probability model. Find the probability that a student won't win extra recess time. So another way of saying that is you can say probability that no recess is really equal to the 1 equals 1 minus the probability of recess. That's using the complement. Does this make sense? Because if you take it one step previously, you would add this to both sides, and you would get probability of recess plus the probability of no recess equals 1. Does this make sense? So I'm just going to use that. So probability of no recess equals probability of 1 minus the probability of getting recess. And probability of recess is 0.5. So 1 minus 0.05. This would give us 0.95. Probability of no recess is equal to 0.95. All right, let's try C together. What is the probability that a student will win stickers? So the probability of stickers is equal to 0.15. Use this to find the probability they will not win stickers. So probability of no stickers, if you want to use the complement, is again 1 minus the probability that you will win stickers. Again, this is the step before it. Probability of stickers plus the probability of no stickers, so yes plus no, will always equal 1. And I'm just kind of subtracting to get what we want, which is probability of no stickers. So if I subtract, or get probability of stickers, which is 0.15, so 1 minus 0.15 will give me 0.85. The probability of no stickers is 0.15. And if you guys remember, here's the way to check in your answer. This is the no, and this is the yes. So in those two numbers, yes plus no is equal to what number? 1. All right, let's move on now to learning target number 3. All right, learning target number 3. Use the addition rule for mutually exclusive events to find the probabilities. All right. When two events have no outcomes in common, we say that they are mutually exclusive. And I'll tell you my sad story, which many of you have seen or personally experienced yourselves. My wife experiences, okay? So this is my story for mutually exclusive. Mom and dad get married and they have kids, dad and mom. But sometimes things cannot work out. So they mutually, which kind of means both, agree, I'm going to write that, both agree to exclude. X means to exit, right? Because if you include, that means you're going to include everybody. But they both agree to exit or get a divorce. And now their lives are totally separate, have nothing in common. You're like, oh, they have kids or something like that. Yes, I understand, or names. But what I'm trying to point out is they mutually or they both agree to exit or leave in this marriage. Okay, it's a sad thing, but it's a reality of life, and I kind of use this in probability because that story kind of is true and it makes sense. Okay, moving on from the sad story. Two events, A and B, are, we just said it, mutually exclusive. If they have no outcomes in common and so never occur together. So they're kind of separate events, but they can never occur together if the probability of A and B happening together is equal to 0. It will never happen. Okay? The addition rule for mutually exclusive events A and B says that the probability of A or B is equal to the probability of A plus probability of B. So I'm only going to highlight this after I read this little note here. Note that this rule only works for mutually exclusive events, meaning they have nothing in common. They mutually agree to exit one another's lives. And if they're mutually exclusive, then you see the word or, then you can actually add the two events A plus B. Let's do an example. How many people live in the U.S. households? According to recent U.S. Census Bureau data, the number of people in the household have the following probability. So if you're just living by yourself, there's a 28% chance. Then 2 people, there's a 34% chance. 16% chance for 3 people in the house, 4, 5, 6, or 7 or more. Okay? Suppose that a household of 4 or more is considered a large household. Okay, so they're just kind of telling us a definition of what it means, what they think is a large household. Randomly select a U.S. household. So they're telling us, find the probability that the number of people in the household is 4 or less. Okay, so another way of writing that is probability that your number is equal to 4 or less than 4. Okay, there's a couple ways you can do this problem. Basically, the probability that's less than 4 is the same thing as saying the probability of someone being 1 person in your household, 2, and probability of 3, and probability of 4. Okay, so if you look above, 1 is at 0.28, 0.34 for 2 people, 3 people is 0.16, and 4 people is 0.13. So if you add those together, then you'll get a probability of 0.91. The probability of getting a household less than 4 is equal to 0.91. Now, I said there's 2 ways of doing this. Well, you can also say You can also say that this is in some ways, if we're saying we want 4, then we're saying not 5, not 6. I'm trying to say that again. Sometimes in this probability, it's faster. Instead of saying yes, in the last problem we said yes to 1 person, yes to 2, yes to 3 people, and yes to 4. And another way of saying that is you're basically saying no to 5 and no to 6. So what's the probability of the complement? And the complement of that, let me write that, of less than 4 is more than 4. Which is the probability of, you can do, or we can say not, sorry, the keyword not, the probability of 4, which is the probability of 5, and probability of 6, which is 1 minus this. Let's just go with that. So 5, what colors have I not used? Purple would be 0.06. Oops, forgot probability of 7 or more. So you're just adding all those up. 0.2 and more than 7 or more, which is 0.01. So this would give us 1 minus 0.09, which would give us 0.91. So remember, those numbers are pretty much the same, right? Okay. And that also we just answered, let's see. Find the probability that the chosen household is a large household. So again, I'm going to go back to what was up here, which is more than 4. So the probability of a large household you can do this in 2 ways. You can do you can just do it straight. What that means, that's the probability of 4 plus probability of 5 plus the probability of 6. And with my magic, that gives us what? 9%. Or you can do the second way of doing this is doing the complement. The complement is probability of large is 1 minus the probability of not large. And so in that case, that would be this one up here. Not large is kind of like the smaller household, which is probability of 1, 2, 3, and 4, which is pretty much what we did up here. And 1 minus that. And that would be 1 minus all of this, which would be 1 minus, that's a lot more work, isn't it? That's why you're always thinking like, whoa. I think I meant to do it all the other way around, huh? Well, I can't add. That's where it is. I got distracted, sorry. What I was going to say is one practical way is like a teacher, or you're counting up the points on your test maybe. Sometimes you're like, oh, I missed one question. What's the point of adding them all up and then subtracting it from, say, 100, like in my classes that I've normally done? And instead of adding up all the points up to maybe say 99, it might just be easier to find the ones that you missed and subtract it from 100%. Okay, go ahead and you guys try example number 4, and then go ahead and press play when you are ready to see the answers. All right, let's go over example number 4. How prevalent is high cholesterol? High cholesterol is bad. Basically, you have too many, I think, like fatty stuff in your blood. Choose an American adult at random. Define 2 events. A is a person has cholesterol level of 240 milligrams per deciliter of blood or above. So I'm going to circle in this one high. And then B, the person has a cholesterol level of 200 to 240 between 200 to less than 240 milligrams deciliter borderline. And I'm going to circle this one borderline. So I just call this one high and this one borderline high, B high. According to the American Heart Association, the probability of A, meaning you get a high cholesterol level, is 0.16, and probability of B, which is borderline high, is 0.29. Explain why the 2 events are mutually exclusive. The events A and B are mutually exclusive because they cannot occur at the same time. You can't be in 2 categories, right? Remember my example about the divorce? You have to mutually agree to be to exit. I mean, you have to go one or the other. Second one is a randomly chosen U.S. American citizen, my stick figure, can't be both high cholesterol and borderline high cholesterol. Okay, so you can't be in 2 groups. It has to be 1 group. 4B, say in plain language what the event A or B is, and then find the probability of A or B. Event A or B means a random U.S. chosen person has either, so it's only, you can either have one choice, either high cholesterol or borderline high cholesterol. And how do you find that probability? Well, says we can apply mutually exclusive addition rule, which is the probability of high or borderline high is equal to the probability of high plus, that's why I circled in red there, probability of borderline high, which is 0.16 plus 0.29, which is probability of 45%. Let C be the event that the person chosen has a cholesterol level below 200 milligrams deciliter, which is basically normal cholesterol. So they're defining the event for us. Find the probability of C. So basically that means if you're below means not high or borderline high. So I said that the probability of normal is equal to 1 minus the probability of high plus the borderline high. Because if you think about it, again, the mathematical step below or above this would have been normal plus, these are all the possible events, borderline high plus high cholesterol is equal to everything. And everything is equal to 1. That's the big idea we have in here. So in the previous, we just said that probability of high is 16 and probability of borderline high is 0.29. Add those together, you have 45. So 1 minus 45 is 55. There's a 55% chance that the randomly selected American adult has normal cholesterol. So we've talked about a probability model. We've talked about the complement. It's kind of like yes plus no equals 1. And then we talked about mutually exclusive events. When you see the word or, you can change it to a plus sign in the addition rule only because they are mutually exclusive. Okay? And that is lesson 4.2. You guys have a good day. Bye.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today. We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today. Listen up and behave. We doing math today. We doing math today.